All right, let's see if I can not screw it up this time. Okay, so what we've got here, got a point. I'm going to put this as 0, 1, 1. And I'm going to head off in the direction of 1, 1, 1. I'm just going to say that's this direction. 1, 1, 1. Okay. Now, we know there's another point somewhere, lives somewhere. And I just happen to know that it's more up in this direction. Because what you're going to find here in a minute, if I'm going to make a vector between these two guys, it's going to look like this. This vector then is what? Well, it's negative 1. No, it's 1. Negative 1. Negative 2. Okay? That's this vector from here to here. That's great. That's not really what I want, Jay. What I want is to know the distance between these two lines. I fully concur with you. That's exactly what you want to know. And so when you do this, there's this triangle here, which of course you're looking for this side. You could also look at it this way and like so. I think I'm going to look at it like so, if you don't mind. Okay. So first things, I'm going to call this guy A, and I'm going to call this guy B. That is 1, 1, 1 is B. So the first thing I want to do is I want to look at a unit vector for B. And so of course that's 1/3. 1 over square. Oh, 1 over square root of 3. 1 over square root of 3. 1 over square root of 3. There you go. That would help. Okay. I kind of screwed that up earlier when I was messing with you guys earlier. Okay. So that's this little fella right here. He's 1 unit long. Awesome. Now, we mentioned in that previous video about finding the vector projection. Okay, this is theta right here. Okay. Well, we know that the cosine of theta is equal to A dot B over the magnitude of A, magnitude of B. That's nice, but you'll notice that if you multiply both sides by A, you get this guy. A dot B over the magnitude of B. Well, that's what you're saying is you're taking the hypotenuse times the cosine. That's going to give you this length right here. That's right. Now, as one can see, the way, because I have this drawn up, I know the answer is going to be, I know it's going to be negative. It's going to be negative in this direction, meaning it's going to go that way. Okay. So A dot B. Well, who are our vectors again? So here's A, and B is this fella here. So that's going to be 1, negative 1, or 1 plus negative 1 rather, plus negative 2 is negative 2. That is our dot product. And of course the magnitude of B is the square root of 3, which is what I screwed up earlier, I think. Part of what I screwed up earlier. So if I were to take this guy here and multiply it by this guy right here, I'm going to get negative 2 over the square root of 3 all the way across, which is, I did have that earlier. Nice. This is the vector projection. The vector projection, that's this guy right here. Okay, well, that's interesting. So what does that do for me? Well, so think about this for a minute. If I want to find this length right here, I take this guy here, A minus this guy, and then I get this value right here. Okay, so if I were to do that, let's see if I can not screw it up this time. Good night, nurse. So it's going to be 1, negative 1, negative 2, minus this guy. So it's going to be plus 2/3, 2/3, 2/3. And so that's going to be 5/3. And then that's going to be negative 1/3. And then that's going to be negative 4/3, I think. And now I need to find the magnitude of this guy. So that's 9, 25/9 plus 1/9 plus 16/9 is equal to square root of 42 over 9, like that, which is equal to, this reduces to 14 over 3, I think. Doesn't it? I think so. Yeah, that looks good. Now let's see where I screwed up earlier, because I think I messed this up earlier. I did. 6. Okay, so then I need to find the magnitude of this guy for right now. So this is what I did wrong earlier, and I know what I did wrong now on the other one when I was saying that. So it's the square root of 2/3. Oops, 2 divided by 3 squared times 3, of course, because there's 3 of them, right? So you get that 2 root. So yeah, so 2 root 3 over 3. 2 root 3 over 3 is the magnitude of that guy, right? So if you take the square root of 6, which is the magnitude of A, minus this guy, you get that god-awful thing. But what is that? I don't know. Let's find out. Wait. Yeah, no. Okay, so something's a little screwy there. Anyway, so whatever. Let me pause for a sec here. Get my bearings here. Oh, so anyway, to answer your question about earlier, that problem on 42, you can't use the problem on page 44. You can't do that one because you're not going from a point to a plane. Okay, you with me? You're going to a point on a vector. Okay, so you're going to want to look over on page 42 where you see what I did right there. That's what I did. And so then it can be simplified over the top of page 43. Okay, and so what that says is that you have the equation of a line. Okay, you have this equation of a line, and then over the square root of a squared plus b squared. Now, I personally think that's a lot of more headache. I would just prefer to do it the way I did it here. I think it's just easier. So all I did once again was I found this is the vector projection matrix right here. This is A, or B rather, if you will. Or well, this is the projection of A onto B. Okay, that's what I found. Okay, now from that, okay, then I'm just going to simply take this vector here, which is our A, minus this guy, so put him tail to head like so. Okay, then I just subtract, and I get this guy right here. And then I find it, and this right here, or if you prefer, the square root of 42 over 3, that should be your thing. The reason that problem on 44 won't work is because that's from a point to a plane. Okay, see, that's the difference. So that's what you got to pay attention on that one. Sorry, I should have caught that earlier. I wasn't thinking.